Okay, this method is bisection method. It is a method which is also called a root finding method. When we say root, it is the value of the x where the function will be equal to 0. Example, x squared minus 1 is equal to 0. So for the example, first we have considered wala bulol na ako. Before we go through the examples, we have considerations to be considered. Fx sub L, or the function of the lower limit times the function of the middle limit or midpoint is less than 0. If that is the case, then x sub m, or the midpoint, is equal to the upper limit. Then fx sub m times the fx sub u less than 0. If that's the case, then xm is equal to the lower limit, or xl. And fx sub l times fx sub m less than 0. If that's the case, xm is equals to the root. Okay, let's consider an example. X cubed is equal to 20. So x cubed minus 20 is equal to 0. We will given the values of lower limit and upper limit. For the lower limit, is equal to 2.5, and for the upper limit is equal to 3.0. Or 2 here is, we made this iteration table for us to easily distinguish the values for x sub l, or lower limit, upper limit, middle limit, and the functions for lower, upper, and middle limit, and also the percentage error of those. So start. Our lower limit is 2.5, our upper limit is 3.0, and for the middle limit, we will use the formula for that: x sub l plus x sub u over 2, x sub l plus x sub u over 2 is equal to lower limit. So for the lower limit, we get the value of 2.75, and for the fx sub l, or function of lower limit, we will be using this equation and plug in the calculator. Minus 20, again 2.5 cube minus 20. Function of the lower limit, we will use this equation: 2.5 cube minus 20. So we get negative. Function of the lower limit, we will use this equation: x cube minus 20. So we will substitute 2.5 cube minus 20. We will get negative 4.375. For the function of x sub m, again we will substitute 3 here. 3 cube minus 20, we will get. And for the function of the middle point, or middle limit, we will use this value: 2.75 cube minus 20, which is equal to 0.79687. And for the function of upper limit, we will use this 3.0 or 3 and plug here 3 cube minus 20, which is equal to 7. And there's no percentage error here.
Bingo.
For the next iteration, as stated here, if xm or a function of xm now, as we notice here, the function of lower limit and the function of middle limit has a change of signs, negative, positive. So going back here, fx sub l times fx sub m is less than 0, so xm is equal to xu. So we will bring down here 2.75 and 2.5 bring down also 2.5 for the lower limit. Again, we will solve for the middle limit, 2.5 plus 2.75 all over 2, which is equal to 2.625. For the function of the lower limit, again, we will use this equation and plug the present lower limit, which is 2.5. Again, we will get negative 4.375. For the middle limit, 2.625 cube minus 20, which is equal to negative 1.9121. And for the upper limit, again, we will plug 2.75 here, 2.75 cube minus 20. We will get here 0.79168. And for the percentage error, the formula there is present minus past over present times 100. Present and past here are the midpoints or xm. So 2.625 minus 2.75 all over 2.625, which is the present, times 100, we get here the negative 4.76119
absolute value.
percent,
Positive absolute. Yeah.
because it is absolute value, so remove negative. For iterations 2 and 3, using the same procedure, finding the negative product or less than 0 product here for fxl and fxm or fxm fxu, and using the conditions above, we will get the values for lower limit, upper limit, and the midpoint or middle limit. And for the functions of xl, xm, xu, using the equation given, x cubed minus 20, we can find the values for these fxl, fxm, and fxu. And for the percentage error, using the formula given here, we will get these two percentage errors.